In this section, we're going to dive right into our first technical topic. We're going to walk through a very small machine learning example. In this example, I want to walk through the entire flow from start to finish of how we might be presented with some problem that could be solved with machine learning, and then walk through some type of imaginary solution. We're not going to write any code just yet. We will very shortly, but for right now, I just want to do a high-level overview on how we would generally approach this problem. So here's the problem. I want you to imagine for a second that you are an analyst at a small city, and your city has a flooding problem. Every year, it rains a whole bunch, and every single year, your city floods. The flood causes some amount of damage, and then it's up to your little city government to pay some amount of money to fix that flooding damage. Now, this ends up being a big problem every single year. So let's imagine for a second that maybe the city manager walks up to you and asks, hey, we're kind of forecasting around 240 millimeters of rain this year. So that means that in total, over the entire year, there's going to be about 240 millimeters of rainfall. So they want to understand how much flood damage there might be as a result of all that rain. Now, this is kind of an interesting problem. How could you possibly guess how much flood damage there would be based upon how much rain falls? Well, let's lay out a possible way of solving this problem. Okay, so here's a series of steps that we're going to walk through to attempt to solve this problem. And we're going to use the same series of steps throughout many other problems that we work on throughout this course. The very first thing that we need to do to solve this problem is attempt to identify data that might be relevant to solve the problem at hand. The problem at hand, we need to somehow understand, given some amount of rainfall, how much damage there might be. So how would we do this? Well, I think that we might be able to come to some conclusion pretty intuitively. I think this makes sense. If the amount of rainfall during a year changes, we're probably going to see a change in the amount of flood damage, or more specifically, the amount of money that we have to pay to fix this flood damage. So if the annual rainfall goes up, we're probably going to have to pay more in flood damage costs. If the rainfall goes down, or if there is no rainfall at all, we're probably not going to have to pay any money for flood damage repairs. So in this case, we would refer to this annual rainfall metric as an independent variable, or alternatively as a feature. And we would refer to the flood damage cost that we have to pay for any given year as the dependent variable of this relationship, or alternatively as a label. So that means that whenever our rainfall changes, we expect to see a change in the flood damage costs. Thus, it is a dependent variable, or we also refer to this as a label. So I think that that kind of pretty closely identifies and relates the data that is relevant to our problem. We probably want to understand how much rain falls in any given year and how much damage that has caused in any previous year. So the next thing we need to do is somehow assemble a set of data using those two relevant metrics related to the problem that we're trying to solve. Now, I want to make one thing really clear throughout this entire course. In a lot of other exercises around machine learning and a lot of online tutorials and what have you, you almost always get presented with this really nice data set. A data set that has already been formatted and is in a nice CSV file or a spreadsheet, and it's really easy to load it up and then somehow run some number of calculations on it. But in the real world, we almost never get these nice data sets prepackaged for us. So one thing that I'm going to really harp on throughout this entire course is making sure that you have the ability to understand how we can collect data, assemble it all together, format it, and then use that to make some type of prediction using machine learning. So with that in mind, I want to approach this problem and think about assembling a set of data right here from scratch. Like if we didn't have this nice spreadsheet at hand that says how much flood damage there was and here's how much it rained each year, how would we actually put this data together? Well, we might do a little bit of on-the-ground research. For example, we might go and find a newspaper snippet from 2009 that says that there was 250 millimeters of rainfall last year. So that would be in 2008. Maybe we then find a YouTube video from 2011 that says in the previous 2 years, there was 197 and 274. And on weather.com, maybe since 2011, there was 291, 136, and 306. Now that's just the amount of rainfall that we found for each year, from maybe 2008 all the way up to 2013 or so. But what about the amount of flood damage? Well, for that, maybe we go and reference like a budget or something like that. Something that says, hey, for these previous years, here's how much money we spent on flood costs or flood repair for each of these years. So you would take both these two sources of data right here and kind of paste them together and eventually end up with a nice looking table like this. Something that relates for every year, the amount of total rainfall that occurred in millimeters and the amount of flood damage money that was spent. So it took, say, $6.2 million to repair all the flood damage in 2013, but maybe in 2012 there was very little rain and we didn't have any flooding, and so there was $0 spent on flood damage repair. So we can consider this right here to be our data set. This is a table of sorts that relates our independent variable of the total rainfall, or our feature of total rainfall, to our dependent variable or label of the amount of flood damage that we spent. Or I should say the amount of money that we spent on repairing flood damage. Okay, so let's take a quick pause right here. When we come back to the next section, we're going to start to talk about how we can decide what type of output we are predicting and what that even means. So let's take a quick pause and I'll see you in just a minute.